Okay, back with part two, which is actually the start of the lesson, and I'm gonna try and keep this short. I've got the one example already ready to go, and whether you have it in front of you or not, that's up to you. But uh, this is my curve sketching algorithm. This is how I remember all the stuff that we can do to come up with a graph in calculus. It's M2I2 acid, M2I2 acid, and I'll talk about what those things mean very shortly here, and then I'm going to go through this example fairly fast. The big thing is for you to practice. You don't have to know M2I2 acid. You could use the one from the book. The CEMC courseware has a checklist of, I think it's about 17 or 18 things that you should be calculating when you talk about sketches. You know, all the different, even asymptotes. There's feels like there's 14 things to do, and that's why. But I break it down to M2I2 acid, and hopefully we'll remember the M2. That's minimums and maximums. So we should be calculating mins and maxes. That's M2, M and M, mins and maxes. The I2, there's two I things, intercepts and inflection. The A is asymptotes, and that's several calculations often. C is concavity. And some algorithms will be, instead of just remembering to check for concavity, they say, okay, make sure the second derivative, when it's positive, that's concave up. When it's negative, all these different things to remember. But I'm hoping that you're going to remember them when you actually apply this algorithm and do some sketches. ID, intervals of increase and decrease. And I almost think of M2I2 acid as a checklist. I got to make sure when I've done a sketch, have I placed the minimums and maximums? Have I placed the points of inflection? It's almost like a checklist. And just like before when we had our curve sketching algorithm, we'll find out that we don't need to do all of them perhaps to get a clear picture. For instance, the one we did in the warm-up didn't have any asymptotes. So we skipped the A part altogether, right? Um, but certainly this will sort of remind us, and we wouldn't necessarily do them in order either, as we'll see. So there's a function we want to sketch, and we would have done a decent job of this in advanced functions, but in this course we can do an awesome job. And once we get the sketch, we know everything about the function. So here we go. So, and again, if you don't have this, you're going to have to pause because I am going to try and go fairly quickly. I started with the asymptotes, which in any rational function usually we do. It doesn't have any vertical asymptotes. Why not? Because the bottom is always positive. It's never zero, so there's no vertical asymptotes, which is too bad because usually that gives us a hint about what the graph looks like. Uh, Horizontal asymptote is y equals 0. And remember, there's our calculus reason why, right, is to do this limit near infinity. And at times on the test, you will be asked to do this, right, and then we talked about, and I'll come back to this, don't worry. I'm talking about the cloud over here. This idea of from above or from below, right? So here we've got um, a number that's a little bit less than uh, -1. This is a little bit, um, I'm sorry, a little bit bigger than -1, like -0.9, because this is positive, and this is the bottom part's a little bit bigger than 1. So we have -1 divided by 1 is going to be from below. So it's going to be a little bit um, less than -1, a little bit lower than -1. So it's going to attract from below. The second part are you notice how I wrote down M2I2 acid, then the intercepts, and I could have been using a table like this, right, which is another tool that we've used, um, where we calculate the intercepts quickly. And then now I'm ready. Notice the second I wasn't ready to do. I'm not ready to do points of inflection yet, because I haven't taken the derivative yet. Critical points. Now I take the derivative, and the derivative is a quotient rule. At least I wrote it as a quotient rule. Derivative of the top, write down the bottom, write down the top, derivative of the bottom, bottom squared, and then I got to set that equal to 0, right? Set that equal to 0. And solve. And there's my collection of points so far. Notice that I can use the quadratic formula on the top, right? Because notice there's no asymptotes here. This is always positive, so I can multiply by that thing. There's no the first derivative is always defined, but it is 0 at these two spots, so I added those to my collection of points. And I should be adding this to a sign chart, although I think my sign chart is in a little bit. We could go to the sign chart now, but let's keep doing some work. Now I'm ready to talk about concavity and inflection. Remember, the first derivative also gives me the intervals of increase and decrease. If I wanted to do that now, I could have. But I took the second derivative, and this is terrible. This second derivative is terrible because remember, there's the first derivative, right? That's y prime. Take the derivative of the top, and it's a linear function. The bottom is awful, right? The bottom is a chain rule question, and some people might have wanted to expand that out, but I left it like that, basically so I could factor, right? I've got a common factor there, common factor that I could take out, and then I common factored that out. It looks like that I expanded all this, and inside I get a cubic. So inside I get a cubic. That means when I set this to be 0, in order to find the points of inflection, I'm going to have to use the quadratic or the factor theorem, right? So I use the factor theorem for that. Unbelievable. See how scared I'm getting? Could be some sweat coming off me there too. Phew. And then the next page is me using the factor theorem. I find a factor that works, and then I do long division. I do long division, and then this thing doesn't factor, but I use the quad formula, so that gives me 1, 2, 3 points of inflection, and we add those to the list of points. There's our points. And we don't, is it a point, are these points of inflection? We don't know, right? We don't know because the second derivative has to change sign, and so that's when we go to our sign chart, and we've written in all these points. We add these points to our sign chart, and yeah, we've actually got 3 points of inflection. We've got where the first derivative is 0 there, and it's concave down, so I know that that's a maximum. We've got a minimum there, and then I can put all this stuff together to come up with a pretty good sketch. Well, sketchy sketch. That's a pretty interesting function. See, we didn't do those in MHF4U because there's lots of things that we would have trouble actually calculating, like points of inflection and so on. There's another point of inflection there. And now I'm happy because I got through it all. No, that's not a function. This is MCV4U now. And that's it. Hopefully you're able to follow that, but you have to practice. You have to practice getting through the M2I2 acid and make it your own. You know, what order do you do stuff? Well, you don't have to copy me. You don't have to copy the book. You're able to come up with your own algorithm as long as it's as complete as this sketch is. I think that's it. Yep, that's it.